Welcome back to this channel. Today we are diving into a powerful concept in Python, that is generators. In this video you will learn why generators matter in Python, what generators are, how to create and use them effectively. To begin with, let us see ways of creating generators in Python. There are two ways of creating generators in Python. One, using generator functions. What are generator functions in Python? Generators are special functions that produce an iterator, but instead of returning all values at a time, they yield one at a time, like that of water tap. They use the keyword yield instead of return. So we create a function similar to that of regular function, which is defined using diff. My function name is myGen, that takes an integer ended by colon. So we have counter I, which is initialized to be 0. Then we do have while loop, which controls I less than n. When the condition happens to be this function yield I, then this statement updates I by 1. This is an increment function. Where this statement is nothing but initialization statement, this statement initializes the counter I. This is while loop, where this produces the current value of the counter, right? This is increment statement by a unit, right? This is nothing but an example of generator function which produces squares of numbers one by one, right? This function does not return a list, it returns a generator object that produces numbers from 0 to n minus 1, one at a time. Each time you call next on it, it resumes from where it left off. Now let us see. If I call the function myGen, what it gives us? This is nothing but it tells us this function is generator function or generator object that occupies certain memory location in our machine. Let me run. Oh, this is nothing but something needs to pass. This 5, for example. Let me run. Right. Because this function takes n as argument and returns sequence of numbers based on this criteria. Right? So what this statement or call function retrieves as it is generator object with name of myGen at certain memory location address named by this one. So directly when we call the generator function in this particular example myGen, it does not return the values, right? It doesn't return the values immediately, right? So we do have another means of retrieving the values of this generator object. For example, we may use for loop for I in myGen 5 print every I, right? We can retrieve the actual values of the counter I through this iteration loop, right? Let me run, right? So what's the contents of each values in our generator function myGen is nothing but 0, 1, 2, 3, 4, because this 5 is exclusive. In other way, we can print these values using the next function, right? using next function, we can retrieve each values of the function of the generator function, the function, right? For example, the print next, right? But first we need to assign this one to an object, gen, for example, right? Now, for every possible value of my generator object, which is gen, I can order to give me the possible values of the generator gen. Let me run this one. This gives me the next possible value to be retrieved. If I order to give the next value, next to one is 2. So give me that 2. To obtain the next 3, right? The next number 4, 4. The next number, if so, yeah, there is no value left to be generated through this generator function. Rather, this statement throws an exception, which signifies that the generator function reaches its end. By throwing this exception message, stop iteration. Generator in Python can also be created using expressions. This ways of creating generator in Python is similar to list comprehensions, but with round brackets instead of curly braces. So what's the syntax of creating generator using expression is given as follows. Syntax generator, which is parenthesis within this expression for item in iterable. We can add simple if else condition here, right? This is nothing but generator expression, right? Where this one is the result expected to have, where this one is the for loop and if else condition. Now this one is said to be generated as it is bounded by brackets, round brackets. But what's the difference with the list comprehension? We make use of this square curly braces. That's the difference in creation, right? So let us see one example how we are going to create generator using expression. Let us see one example. Generator function or expression, expression that doubles the numbers in a range, right? This can be created, for example, double nums is the name of the generator object. Now the expression is x that doubles by 2 for x in range. For example, let me say 5. Let me run. Right. Now this is nothing but generator expression that assigns to dnums object. Right. Now in this example, each call to next dnums object retrieves the next computed value. Just like generator function with yield, it does not create a list. Right? Similar to that of generator function with yield, this dnums does not retrieve the exact numbers of the dnums object. Right? For example, print dnums. What this prints? This is nothing but it retrieves this dnums is a generator object with certain memory address. Let me run. Right. This is nothing but generator object with created by generator expression and occupied with this memory address in our machine. If it had been a list, this would result the exact values of the list in list structure. But this is the difference with that of list. This prints as it is object, right? But the values remain on receive, right? On fly. So how can we print the exact values of this generator object? We can make use of for loop or the next function. Using the for loop, we can print each possible values of this generator function or generator object, right? For example, for loop for I in dynams is iterator. Now print the actual values of I. What are the possible values of this generator object? Is nothing but x. When x is 0, we double it based on this expression. 0 times 2 is 0, is 2, then 2 times 2 is 4. So based on this expression formula, this dynams generator object contains all possible values, right? So this retrieves the following: 0, 2, 4, 6, 8, right? 2 times 1 is 2, 0 times 2 is 0, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, right? This is through for loop to retrieve all possible values of the generator object dynams. We can also make use of the next function to retrieve these actual values one by one. The other way of retrieving the possible values of the generator expression or generator object dynams is making use of next function. Print next dynams. Dynams by itself is now an object, so it can pass immediately as is to this next function. So we can guess what's the output of this print function. This is nothing but the first element of dynam. Let me run. This is nothing but 0. So now Python waits to retrieve the next number, right, as per our request. No, let me rewrite this one and let me run. This gives us the next number 2. This is similar action to that of generator function. The yield function is the same for both the generator using expression and the generator using the function. And the next order prints the next number 4, right? Then the next 6, then next 8. So guess what will be the next if I run this one? This will be exception signal. It is not an error by itself. This signal tells us where this generator expression or generator object reaches its end. There is no legal value to retrieve based on the condition given in the expression here, right? This range is limited to have 5 elements from 0 to n-1, which is 4. So generator using expression retrieves the same signal as we did it in the generator function. So let us see. Now let us compare the memory occupation by each object, by the generator and by the list data structure. Let us see. For example, we do have two lists: my list, which is created by this list compression, my gen, which is created by this one. The range here, the squares is the same, right? 1 million range. Now prints his get size of to obtain the memory usage by each object. We may use the get size function from sys module. So let us see what the difference is. Now this memory occupation is from the list object, whereas this 192 from my generator. Small memory is occupied by the generator, whereas large memory occupied by the list. So from this we can understand that all values generated by the generator not duplicate onto the memory as is, but they stay on the fly. This makes generator saves memory significantly, whereas list deploys what it has to the memory. So that occupies highest memory space in our machine. So what the first significance of generator is nothing but to save memory. Now we are coming to end. When to use generators? This is for the sake of recapping. We use generators to take the advantage of generators when we are working with large or infinite data, or we use generators to optimize memory in general. or we may use in streaming or real-time processing, right? In, for example, in API responses. And they are especially useful in data science pipelines, file analysis, web scraping, statistical simulations. So generators are much useful in real applications. Thank you for watching. Don't forget subscribing this channel to stay ahead with me.